I usually leave about 10:30 because I have to go to the school for my math class.
Okay. Okay, this is just question. There we go. That's right. All right. So we looked at electron configuration the last time, and it seemed that pretty much you all got it.
Yeah.
Yeah. All right. So there is a part in here that I don't have anything on here. And this is the part I had told you that we were going to do, which is the weird part, which is the math part of this. I had told you there's no more math, and I totally forgot that there's that one piece of math that we have to do. And so I think what we're going to do is we're going to go to connect so I can show you where it is, the math,
Okay.
and then we can do some of those problems based on that. That way it'll work better. Okay, here we go. Hopefully this will work, because it is a little different. It's wavelength, and I can teach you about wavelength here in a minute, but I just want you to get these formulas, and that's the main thing. Okay, so the assignment itself, I think it's where we want to go, and I'm just gonna skip all the questions that don't have any, that don't relate to this one topic. Okay, there are 36 questions on this one. See, like categorize the wave. Okay, so this is what I was telling you. Okay, with this one, it works really well. So if you have a wave and the wave is really wide, like this one, right?
Okay.
Think about how lazy, right? It feels lazy. Yes?
Yes.
Lazy. Okay, so lazy wave means lowest energy. See? Isn't that cool?
Okay, that's pretty simple.
Yeah, it works really well. Lazy wave, lowest energy. Now, as far as how much distance it'll travel, they all travel the same amount, okay, of distance. However, how many waves pass through the certain point, it's also low, which is a low frequency, right?
Mm-hmm.
Now, but the length of the wavelength is it. You see that? Does that make sense?
Yes.
Okay, so highest energy would obviously be this guy, because he's really, really like almost frantic, right? It's just like constant up and down, up and down, up and down. And then that makes it the highest frequency also, because more of these are going to pass that one point in a certain amount of time. And that's what frequency is. And then, of course, this is the shortest wavelength because it travels less per wave, right?
Yeah.
Okay, so see, that makes sense, right? They all kind of go together.
Yeah.
Okay. All right, so that's that one. And let's see, where is my check thing? Oh, I think it might be. Yep, sure enough. It was under our faces because it does that. Okay, so I see they're all correct because it makes sense. I mean, these make sense a lot. Wavelength does make sense a lot. Okay, so the electromagnetic spectrum, okay, and the highest is radio waves. There you go. Radio waves, if I'm not mistaken, it's microwave, then infrared, which means below red, then visible, then ultraviolet, which is after violet, right? Then
Mm-hmm.
X-rays, and the last one is gamma rays. Gamma rays, oh, sorry, I did them backwards. Energy. I wasn't reading. I was putting them in order that I know them as far as wavelength goes. Oops.
Oh.
Yeah, they're all backwards, exactly backwards, as a matter of fact. Highest energy is going to be the ultraviolet. I had them right. It's just that they're backwards. So I'm going to just read.
So the X-rays
Right,
and
then
then
visible, because, oh, sorry, ultraviolet, where are you? I don't know, I moved you in the wrong place. What did I do? Oh my gosh, I thought I had gamma rays there. God, I'm blind. All right, there we go. Okay, so basically
and then
gamma
visible.
rays, yeah. Then X-rays, which you know X-rays penetrate your body.
Yeah.
and you can see it. And then ultraviolet is below violet, which in a minute you'll remember something. Infrared
Then infrared.
after, before red is what it means. And then you
Okay.
got microwaves, which are sort of penetrating, and radio waves, which do not. Okay, so if you remember this acronym, this will help you. I think you will once I do it. You remember
Oh, G,
Vib?
Vib. Isn't that the rainbow?
Yes. Okay.
Oh,
So see, if you flip it, right, then this is how it's flipped here. So visible is this right here, except it's backwards, because it would be BG word, which is totally not the right way that we remember it, but it would be flipped here. Because see, ultraviolet, oops, and I did this backwards. Man, I'm bad today. My brain
it's
is,
okay.
yeah, I did this one backwards. It's violet first. I mean, blue first, then indigo, then violet. I don't know what I just noticed it. Okay, there we go. Because violet is ultraviolet
Yeah.
and here infrared. See?
Yeah.
Sense, right? Infra means below. And so that's below red. And ultraviolet means beyond violet. So that makes sense if you flip it. Like I said, it's flipped in this case. All right, so that's the acronym you need to remember. And let me clear that. All right. Okay, so let's keep going. Okay, this time is right. I know. Oh, I need my, I have to change tools every time. Yeah, see? Because radio waves are very long, and this is what we did earlier. So this is by energy, right? Decreasing energy. So the longer ones are the lazy ones, and the shorter ones are the frantic ones. So the ones that have more energy. All right. And this one, okay, here it is. This is the ones you need to know.
Okay.
Okay, so these are the three equations, and I'm going to write them down because it's one of those things that nu, that V that looks like a V, that is nu.
Mm-hmm.
And nu is the frequency, and lambda, which looks like a inverted Y kind of, that's that's the wavelength, frequency and wavelength. And H is a constant and C is a constant.
Okay.
The constant is called Planck's constant, and the E constant is the speed of light. I'm sorry, the C constant is the speed of light. E is just stands for energy. And if you notice, what they did is they actually substituted the solving of this equation in here, in
Yeah.
here. Yeah, you can see that, right? The C is actually down here. Yeah, it's kind of weird. It's just what they did. They took the nu and put those other ones in there because it's HC, right?
Mm-hmm.
Okay, so let's see. C HC over lambda. Okay, so to label. All right, so C is meters per second because it's the speed of light. So
Okay.
you gotta remember the units. That's the main thing. The wavelength is just how many. Well, normally wavelength is not in meters, but it's in nanometers. But let's put it in meters. Okay. Nu is frequency, which is hertz, which is over seconds. It's per second, right? It's how many things it goes per second, and there's no actual name for it. So it's wavelengths per second. And then that's it for that one. E is energy. Energy is joules, as you know.
Mm-hmm.
Okay. Nu again is going to be second negative. We know all of these. You can just put those in, all of these. Okay. And I'm trying to leave the last two alone just so that you can see that it's easy to figure them out too. All right, so energy is joules, but joule, what is a joule? Well, joule is actually all of this, so it is H, which we haven't put on there yet. H is the units of Planck's constant, which
Okay.
is joules second. Yeah, no, it's not joules second. What is it? Where are you? Maybe it's, I don't think it's unitless. But lambda, I know that's meters. Well, obviously here's meters, but no, it's never meters inverted. So I'm going to say it's joules second because joules is joules. See, that's going to be joules second. Yep. Yep. That is definitely joules second. Yep. 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 Because you get rid of, when you multiply these two, you get rid of the S. You see that?
Mm-hmm.
See, you can figure out the units by just doing that. Yeah, there you go. That's it right there. All right, little girl, let's go. I have kitties. Like you have your puppy, I have my kitties. So they're right there in front of me. She's
I have one cat. She's old.
oh, mine are new. Well, fairly new. She's 3 years old, more or less, and he is a year old. So
Okay.
okay, so that's okay. Remember these units because that might be something to take a picture of.
Yeah.
We'll make sure they're right. Yeah, they are. Okay, stay put. This kitty, sometimes she'll walk right across my screen. I mean, my keyboard, and that's why I'm trying to get her to stay put. She is just so nosy. Oh, now she's playing. She's playing with the this, what do you call it, the screen bar.
Oh,
Ah, come on. Let me open the blinds for you. There you go. Now you can see
so
right. Yeah. Now
you said that C is Planck's
Planck's
constant?
constant, yes. Remember? Oh no, H. Sorry,
Oh,
H.
H is the Planck's
Yeah,
one.
C is the speed of light. Okay, so this will help you also know what you're doing. So, where are you? There's no right bricks. Okay, there you go. Frequency and wavelength. Remember that? So the
Mm-hmm.
speed of light is equal to the frequency times the wavelength.
Okay.
Energy is equal to Planck's constant times
Frequency.
frequency, correct? And
And
then
then energy.
down there also, you can put it either way. It just depends on what information you have. You use either one of these two energy equations to calculate it. But sometimes you just need one, the one with the new, but sometimes
Mm-hmm.
they only give you the wavelengths, so you got to do the other one. All right, so
So
this
the
is
last one is energy equals Planck's constant times speed of light over wavelength.
correct.
Sweet.
And there you go. All right, so those are all of your see, these are easy, right? These are easy to just label. But now the next part's not so easy. Yeah, this is the application of them. Okay, this we're gonna skip for now.
Oh,
Because
take it.
it's a little bit okay. So basically, it's a little bit of a thing that you have to actually look at your table that's in the book. So we're just gonna skip these for now because I'm trying to teach you the other part first. Okay,
Okay.
yeah, this one too. Nope, 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 nope.
They really want us to learn this, apparently.
Yeah, they do. They do. And these are the quantum numbers. Okay, so the quantum numbers, and they pull it principal, and it's principal, P-A-L, not principal.
Oh, okay.
Oh, I hate when people make mistakes. All right, the symbol is the M. The principal quantum number is M. But where is M? There is no
There's an M with a little I or
I
L, whatever
know.
that
I
is.
don't remember that being like that, but I guess it is.
And there's an M with an S.
Hmm. Property is the orbital shape. That determines whether you're an S, P, D, or F. Okay, we have magnetic. Spin is the last one. That's this one. But that's not the magnetic. I think that's the other one that I can never remember. They call it the angular momentum? I always knew it as a model, and that is a weird name, I know, but that's how I learned it. So I'm not find it. Okay, we'll skip this one for now. I have to go look at the actual book and see what it, because it's different from what I learned. All right. Nah, we're just gonna skip. Oh no, this one's just putting in remember how we did that? It says the partial orbital diagrams for the indicated elements. Okay, so all you need is your periodic table. This one's easy. Just take your periodic table. If I can find mine, that would be nice. Where did you go, periodic table? Gee, I put it under something so it wouldn't blow away because I have a fan blowing in my office right now. And oh, there it is. Found it. Okay, so periodic table, basically, and you're just gonna take, okay, so cobalt. Okay, cobalt is all the way to 1, 2, 3, 4, 5, 6, 7. So it's 7 in the D's. So we're gonna do the D's first. So it's gonna be here, right? And it's 7 of them. So we got 1. No, that would be 2. That would be doubled because it's 7. So it's 2 plus, the half all full, right? And the other half not full. The other third, the 3 not full. So that makes it 7. And the 4s is full. And there is no 4p because cobalt stops there. Okay, copper. Copper, remember, is an exception. So we got to put it full all the way. And the 1 in there, because this is the one that we. Okay, empty. There's no empty. Well, I guess we just put empty on these. Yeah. I guess. I'm guessing that's what they says. Do not leave any boxes unfilled. Yeah, so empty. This one too is empty. Empty, right? It's just, I'm reading the directions. Okay, selenium is beyond copper. So we're going to have the same exact thing, except this time these two are going to be full. All of these are going to be full. And selenium is on P1, 2, 3, 4, right? P4, is that what you see on selenium?
Yeah.
Okay. So that means one of these is going to be full and the other ones are going to be 1, 1, 1, right?
Yes.
All right. And obviously this is the extra part that isn't in, they would all be what? Argon, right? So argon, so you got your 18 from argon, and then you've got the ones that we put on there. So 2, 4, 6, 8, and 1, 9, and that is 18 plus 9 is 26. Oh. And guess what? That's exactly how many electrons there are, right? And 18,
okay.
Yeah, see, 18 plus 2, 4, 6. So that's 11. 18 plus 11 is 29. That's how many there are in copper, you see. And 18 plus 2, 4, 6, 8, 10, 12, 14, 16. 18 plus 16 is going to be 34. See? And that works. So these are correct. All right, so check the work. Make sure it's correct. Should be. Yeah, see? And that's it. That was easy. That was just an orbital diagram. Okay, this is see, all I want you to do is put the 2's on there. So like nitrogen is 1s2, 2s2, and 2p3, I believe, because it's n5. So yeah, there. Chlorine is 1s2, 2s2, 2p6. Obviously, if they're past it, they're full, right? S2 and 3p5 in this one because Chlorine is in group 7. That's how I'm doing it. I'm not even looking at my periodic table. Sodium is 1s2, and that is on 1. So the last one's going to have to be 1. See? And then this beryllium, it's actually 2s2, beryllium. Yeah, beryllium is 2s2, and that's it. There's no more. Yep, and there you go. So that's how you complete those. Those are easy.
Yeah.
See? So just drag and drop.
Not bad.
All right. This is the condensed. Okay, same thing, right? So manganese is Mn, and that is 4D1, 3D1, 2, 3, 4, 5, 3D5. Okay, so first 2, 3D5. And if you want to make sure argon is 18 plus 7 is what? 25, correct?
Yeah.
Right? See? Calcium is 4s2 because calcium is actually krypton, which is 38, right? Plus 2
Yes.
40. I mean, 38.
Wait.
I'm sorry. I'm looking
No.
I'm thinking of the next one. Sorry. 18 plus 2 is 20. Sorry.
Yeah.
I'm thinking of the mass number. All right, chromium Z4. Okay, chromium is an exception. Remember that one also? So it's D5, but you still got 6 electrons more than the 18. So 18 plus 6 is 24. You see? Germanium, okay, germanium, Ge, you are in piece 2. So these are all full. So 2s2, D10, and P2. Last I looked, let me check, make sure. 1, 2, yep, that's it. All right. And
Okay.
there it is. That's the condensed, and it's correct. And if you want to add 32, right? So argon, this is the one that is 18 plus 20, 32. Yep, that's correct. All right, so there you go. And that should be correct. If all right, chlorine. How many unpaired electrons? Okay, so how did you do that? You do the shortcut configuration for chlorine, and then you'll know, right? The ending. All right. So the ending for chlorine is, let's see, where are you, chlorine? It's going to be neon, right? And it's going to be 3s2 and 3p5. Okay. So the s2 is not unpaired, but the p5, there's 1 unpaired electron, right? Because
So
it's normally 6.
Oh, okay. So you just put a 1 right there because there's just
Oh,
one
I
left.
gotta drag it. I was trying to write it in and it wouldn't let me, but I just
Oh,
realized, yeah. All right. So do you see why? Because it's P5. Okay,
yeah.
so selenium is, we don't even have to do anything else except the P's. Selenium, where are you, selenium? Okay, so it's P4. That means you have 2 unpaired electrons. Yes?
Because it's usually 6.
Exactly. Makes sense, right?
Yeah.
Cesium?
Um.
Oh, wait, no. Selenium would be 3. Oops, nope. I'm backwards. I said it's 4 right now, right? And
Yeah.
remember, okay, so you have to visualize. Okay, you have to visualize this. Okay, oops. What?
Oh.
What happened? Oh,
Oh, you clicked on the tab next to it. Go to the top and click on Chapter 7 assignment on your tab.
oh, okay. I accidentally clipped. I don't even know how I did that. Okay. All right. So I was trying to get the draw tool and I did it with my finger. I should have done it with. Okay. So this is what we're doing. So we're doing the P6s, right?
Okay.
And this is P5 because we know we're in 5. See? 1 unpaired electron. This one is P4. It's going to be 1, 2, 3, 4. So it's 2 unpaired electrons. That's what I was saying. It's not. Okay. Yeah.
Mm-hmm.
The next one is cesium. Oh my God, my kitties. Of cesium. Okay, cesium has one unpaired electron because it's on the S, right?
Mm-hmm.
And it's only S1, so it's just one again. And
Okay.
phosphorus, P5. Okay, so phosphorus is in the third one, so 3 unpaired electrons because it's 3. And when you do the, okay, so this one would have been, okay, this one would have been the S, right? And it would have just been like that. And then this one would be like this, and each one would have 1, you see?
Yes.
So that makes it 3. All right, so check it, make sure it's correct. Well, no, it's correct, but just so you can see it. See, it makes sense to do it this way. It's faster. All right, next. Let me clear all this junk because it's going to be in the way of everything. Okay, same here. Okay, so they want you to say who this is. You see that?
Mm-hmm.
Okay, so you can cheat one way or you can actually find it the way that I would do it. Okay, if you look at the P, you
Okay.
got 1, 2, and it's on 2p2. So 2p2 is carbon. You see that?
Oh, okay. So that's just C.
Right. See how it makes sense? Because it's 2p and there's 2 electrons. All right. This one is 3d5.
Mm-hmm.
Okay, so 3d5, just count the d5s, and it's 3, so it's the first one. So 1, 2, 3, 4, 5. It's manganese.
Oh, okay.
Does that make sense how I did it?
Kinda, yeah.
Or you can count all the arrows. Be my guest. And
Probably not.
and that's another way, you can count them. That's kind of cheating though. 2, 4, 6, that's carbon. You see that?
Yeah.
And then 2, 4, 6, 8, 10, 12, 14, 16, 18, 25. Who is 25? Manganese.
Okay, I see. I see.
See? So that's two ways of doing it. But the easier way is just looking at the D, and you know where 3D is, and then just count from the edge of the D's and go 1, 2, 3, 4, 5, and you hit manganese. And there you go. And if this had been 1, right here, then this would not be manganese. They would be chromium. Remember that, because you got to look at the S also. This S2 right here.
Mm-hmm.
I'm talking about this one. I don't have my my pointer, which is there. All right, that's next. Oh, check it. I guess it's okay to check it like that. Yeah, see. It's correct. All right, so next. All right, let's see. Identify electrons, element and valence electrons in orbital diagram C. Oh, so you just gotta highlight it. Okay, so I'll let you do it.
Oh, so you would just click on the C, right?
Yeah, see, it's C. There
And
you
then
go.
and then you
There
would
you
click
go.
on.
Yeah, I was letting you do it, like tell me, and I would click on it. Yeah, because I don't
Oh,
think I don't think I've given you control, but I can if you want. Identify.
but
Okay.
it said that you had to click on the corresponding valence electrons too. So weren't we supposed to click on the two little
Oh,
air?
oh. Let's go back.
Yeah, go back
I
because
was not reading.
you
The
don't have to click
valence
on the two
electrons.
arrows there
Okay,
next
so
to
the
the two
valence
P.
electrons are actually these, this
Oh,
one, this one, and this one, because it's in group 4A.
well, I had two of the four.
Okay, you know why it's all of them? Because they're
No.
both 2, see? They're both on the outer shell. You see that?
Oh, okay, okay, that
Mm-hmm.
makes sense.
Yeah. Okay, so let's check it now. Now that we
Yeah,
did it right. See? I didn't read that part. I just skipped it. I was
that's
just
okay.
identifying the yeah, thank you for reading. All right, so who would this be? Okay, how would we know? Remember, always look at the last ones.
So you would look at the 4S or the 3P?
Uh-huh. No, the 4S.
The 4S.
Yeah, always the highest.
Okay, so
And that gives you the location of the play of your element.
um, is that one the MG one?
No. Okay, look, 4. Okay, so when you're looking at your periodic table, let me bring up our periodic table if I can find one. Yeah, right here. I think I can find it here real quick. This is not like in class. I can really roll this up fast.
Does it matter which periodic table I'm looking at?
Well, we have a no, it doesn't. I'm just bringing up a periodic table to show you how to look for it. Okay, so this is the periodic table. Okay. All right. So it says 4s. So remember these are numbered, right? In your periodic table that I gave you, it's 1, 2, 3, 4, 5, 6, and 7, right? And S's are these, right?
Or the little groups?
4s, 2. See?
Oh.
Makes sense, right? To find it like that. So
is the S, is it like every 2 little groups, or is it every column that's an
no,
S?
S, all of those are S. Every one of those is an S. And S1 for the first column, S2 for the second column.
Oh, okay. I was doing it backwards.
And then these over here are P's, right? You remember that? These, oh, okay. These right here are the P's, right? And you notice it's P1, P2, P3, P4, P5, and P6, you see? And then
I don't know, it froze. What's a P?
Oh, the P, the electrons, the P's.
Oh.
These are these, and these are n-1. And remember the n is these numbers right here, the ones I just drew. All right, so n-1, when they told you 3d5, you go 1, 2, 3, 4, 5. And there's, see? That's how I find them.
So this one is calcium, the one that we're on.
Yes, correct.
And then the valence electrons
are going to be the last one. Only the highest one. Oh, sorry, that's a big mess in there. Only the highest one that are on there. So which one's
the 4s?
The 4s, correct. So you're going to have to click this one and put calcium. And that's it. That's our valence. And see, it's in group 2, right? 2A. Then it matches, you see?
Okay.
And it's in period 4. So, all right, next. All right, let's see if that one's going to do the same. Okay. Notice what it's saying. It says, select the group on the periodic table with an electron configuration of N, S2, N1, D10, and NP5. Okay, so any of these would be good. So the group P5 is going to be this one.
Okay.
But
okay,
the problem is there's no D's in the middle here. So why would they do that? Oh, well, it doesn't matter. I would say bring it down more, but it doesn't allow you to shrink it. So I guess this is where it would be. Basically, where would it locate? Where would this be located in that column? That's what they're saying. Okay. They're generalized. It's not exact, but that worked. Oops. Let's see. We didn't even check. Make sure it's correct. Oh, I went too far. All right. Check it. Yeah, it should be correct. Yeah, see, it is. Okay, because of the P5. See, all I was looking for was P5.
Okay.
But I'm trying to teach you. If you look at just the thing that they're giving you, and you know which one's S, P, D, and F, right? Then you can locate anything. All right, let's go to the next one. This one's the same thing. Okay, so this one is.
So that one's looking for D3.
Right. So D3, you're going to be 1, 2, 3, and these are all D's right there. See?
Yeah.
Makes sense, right?
Yes.
See? All right, next one. Okay, this we haven't done. We have not done ions, so we're going to skip this one. That's coming, but I wanted to take a little. Yep. Okay, see, ions having the same atomic configuration as their noble gases. Remember, I keep pointing that out every time. Okay, these we have done. Periodicity, nah. We don't need to do that one unless you want to.
We can.
Okay. You want to do one of those? Okay, let's go back. Okay,
Just for
so
fun.
atomic radius. Remember, atomic radius, and I'm going to draw the little trend, increases, right? That way.
Mhm.
Okay, so the highest one of those is going to be the lowest that we have on and farthest to the left. So rubidium, do we have cesium? No. So apparently rubidium is going to be it. Yeah. Yeah, rubidium would be the one. Okay, so we're gonna, if I find another one, I'll move it, but I believe that's rubidium. And then the lowest one after that is this guy, right?
Yeah.
Okay, because it's right next to it. Then calcium. Do you see how calcium's right next to it?
Mm-hmm.
But it going opposite direction of my arrows. So that means it's smaller. Then we have arsenic, chlorine, argon, phosphorus. Okay, so where are you? Arsenic. I'm trying to find all these. Arsenic. Okay, so arsenic I think would be next. And then we've got phosphorus right above it. You see that?
Yeah.
And then we got chlorine.
And then
Argon. Right, that's the smallest because it's the farthest to the right. I believe this is correct. Let's check.
nope.
Yep. See, all of
Oh
it.
yes, I did backwards. Wait,
Oh, you didn't do it right.
I can't read. Hold on.
Okay.
I put AR and AS backwards.
Oh yeah.
The
Like I
letters are
was doing,
small.
not reading enough. Just the
The letters
A.
are very small.
Yeah, I know they are small. I can make it a little bit bigger. Well, not right now because I don't have my mouse on me.
Children,
Children.
stop it.
They are cute.
You are 85 pounds. He is 2 ounces. Stop it. Thank you.
They are
Sorry.
plain. No, that's fine. All right. So in this case, okay, so we've got ions. And this is where we have to think, which noble gas are we looking at? Okay.
Okay.
So calcium is going to be noble gas argon. Okay, so we're just going to put it under here. Oops, well, we cannot put it under there. In fact, I can write on it. Okay, so argon. This one is also argon. Chlorine is also argon. Okay. This is going to be interesting. Phosphorus is also argon. Okay, so much for putting the noble gas down there, huh? Okay, let's see. This is interesting. And SP, what does it say? S. Okay, I cannot read that. SP2, what does it say? SP2, SP. What on earth? I don't get it.
I got nothing.
I do not get that one. I don't know what that means. So we're just gonna see what we get. Okay, so largest. This one's gonna be tricky because calcium would be the potassium, sorry, would be the largest, but it gets smaller,
Mm-hmm.
right? As when it becomes an ion, but it gets smaller the more electrons you lose. So I'm guessing this is how it's going to be. I'm guessing, don't ask me, I don't know. And then I'm putting this one in the middle. I don't know. I'm really just guessing with this one
The
because
chlorine is in the middle.
the chlorine is in the middle.
Yeah.
This one?
That's the only one I'm getting right.
Oh, really?
Yeah.
So
I have
you have the same one?
Yeah, I have the same question, that I'm looking
Okay,
at.
so chlorine then, okay, so then this one must be here. I don't
And
know what
chlorine
this
is.
means. Oh, too negative. That's what it means. I think. Maybe. Let's see. Check it.
Um,
Yes. Okay. That's what it means. Okay. I got you.
okay.
All right. So the more electrons you add, obviously,
Mhm.
the largest it gets. So I didn't realize that until just now. But actually, the truth is that phosphorus was larger already.
Oh.
See, and the reason I put them like that is the more electrons you lose. So you know that the pluses are going to be the smallest
Mm-hmm.
because they all get to look like argon, but they already started a certain way. So no, you can't do that with these. They're all argon. So
Okay.
the smallest is going to have to be the one that lost the most electrons. And
Mm-hmm.
then the one that still lost electrons would be the next one. And then after that, you have to go by size because they were already larger. So chlorine was smaller, but phosphorus was larger because it's more in the middle, more towards the right. And remember, atomic radius increases going that way, but this is ionic radius. So
Mm-hmm.
that's where the problem is. They put it atomic radius, but it's not.
Oh.
It's ionic radius. They didn't
Well,
put
alrighty.
it correctly. Yeah, they did not put this correctly. But this right here was confusing until I saw the two negative. Then I said, that's where it's got to be in the middle.
They
Because
just wrote it kind of funny.
it's anything two negative. So two negative in that one row, right? It's going to
Mm-hmm.
be sulfur. That would be sulfur. Mm-hmm. No, not sulfur. Yeah, it is sulfur. Phosphorus, sulfur, then chlorine. That would be the right order of size because they get progressively bigger, but they already were bigger. So phosphorus was already bigger than sulfur, and sulfur was already bigger than chlorine. So there you go. Does that kind of make sense?
Yes.
Okay. Let's go to the next one. All right. Get it clear all this mess. All right. Now here you have to say which one's bigger, lithium or nitrogen. And this is atomic radius. This is easy. You just go to the lithium and you know that's going to be the biggest because it's farther to the left, right?
Yeah.
And bromine or bromide ion. See, this is where it gets bigger. The bromide ion gets bigger.
Is
Now,
that because it has that
calcium
minus
ion,
sign?
yes, because it gains electrons and it expands. Whereas this one is losing electrons, so it's losing a layer.
Okay.
Argon and neon, okay, so it increases going down, and argon is below neon, so argon is larger.
Okay.
Oxygen and sulfur. Oxygen is right above sulfur, so guess who's
It's
bigger?
larger.
Yeah, sulfur is larger. Yeah, because what are you going down? Sodium
Yeah.
and magnesium. Okay, remember what we did? The one that lost the more electrons is the largest, the smallest. Sorry. So
So magnesium's the smallest?
yeah, and it already started off as bigger anyway. Sodium did. So okay, N3 and O2. Okay, O2 is going to be larger, no, smaller, because it already started off as smaller. In Al3 and P-3. Okay, this is where you got to look
Bigger?
at. Yeah, the P is going to be bigger because they're both in the same row. So that means aluminum, when it loses, looks like neon. And phosphorus, when it gains, it looks like argon. And argon is bigger than neon. So this one. See? Let's check it, make sure that's correct. But I believe that it all is. Yeah, see?
Mm-hmm.
So that made sense. All right, next one. All right, so this one, increasing. Okay, so this is all about atomic radius, obviously. They haven't done any other trends yet. All right, so increasing atomic radius. Okay, so we know that the largest is going to be the one that's farthest over and down. So that would be sodium, right? right?
Yes.
The largest over to the left and down. The
So
farthest
is
down.
lithium the
And
one
I
that's
don't
right
see
in front of that
anybody.
one?
Then lithium would be next. Yes, correct. And then you've got beryllium, no. Boron. Boron would be next. Then
Boron, and
after
then
boron, then you've
neon,
got neon. No, not
no,
nitrogen. See,
nitrogen,
then neon. Neon's the smallest. Yeah. See, I did him backwards, but because I'm used to looking at him that way. But you know, if you actually had to write him, you can do it also.
whatever works.
Yeah. Oh, let's check and make sure it's correct. It should be.
Yes.
Okay. All right. Isoelectric. Remember isoelectric series? That means they all contain the same amount of electrons, which is annoying.
Huh.
Yeah. But then you have to put them in order of increasing size. And this does not exist. This does. Okay, so magnesium and sodium. Sodium is going to be, no, there. Magnesium is going to be here. There's no magnesium negative. And they have to be isoelectric, which means they have to have the same number of electrons, right? So sodium has 10, magnesium has 10, right?
Okay.
I mean iron, like this. Once it loses one, it has 10. When it loses two, it also has 10. Aluminum is not on there, okay. Silicon is not on there, okay. Phosphorus is not on there either.
What about oxygen?
Yeah, we've got nitrogen. Ah, no, we got nitrogen. Nitrogen is next. Nitrogen would be the biggest one. Oxygen 2 negative would be next, and then fluoride.
Okay, so nitrogen,
Because they all
oxygen.
look like neon now, see? So look.
Oh, okay.
So 12 minus 2 is 10, right? 11 minus 1 is 10. 7 plus 3 is 10. Wait, yeah, sorry, I lost my way. So 8 plus 2 is 10, and 9 plus 1 is also 10. See, that's what they wanted. Okay, so check the work. Should be okay. It's not. Oh, these two are backwards. Yeah, I always get those backwards. You know why, right?
Yep.
Because of I even told you this, the amount of electrons that you lose is, okay, so return to question, and we just flip those two. Yep. There we go. Yeah, we did this already, pretty much. Yeah. Now they're correct. Yeah. It's because fluorine is smaller already. Yeah.
Yes.
Yeah. Okay. I don't know why I did that backwards, but I did it backwards. Anyway, so there you go. Next. All right. Okay. There we go. Ionization energy. All right. Remember, ionization energy is exactly backwards from those arrows we drew before. So this time they're going this way and up. So, and they do include the noble gases. So the highest one is going to be helium, obviously, because it is the top of all of those, right?
Yes. And then lithium.
Oh, lithium's probably the smallest.
Yeah, like lithium right behind the helium.
Yeah, no, that's beryllium. Let's see, helium. I think lithium's gonna be your lowest because it's over here on this side. I mean, if you look at it, it's over on this side of the periodic table, which is all the lowest.
Okay.
It increases towards the arrowhead.
Yeah.
So oxygen, maybe? Yeah, I don't see anything else. I think oxygen, then nitrogen, right?
It wouldn't be boron?
No, next would be boron. See, look at your periodic table. See how you're going helium? You're kind of making an L. Helium, then come down, and then the first one you encounter going towards the left would be oxygen, right? Then
Yeah, I
after
skipped
that, you
over
would encounter nitrogen. Then you would encounter boron, and last you would encounter lithium. And that's kind of how it should be, I believe. Let's check. Oh, these two are backwards. Okay, so with you, okay, these are backwards. And why are they backwards? Okay, you notice it doesn't say to use the periodic table. Maybe they want you to actually look for them. That's ridiculous. You're not doing anything doing that. Because oxygen is first, then nitrogen. If you look.
Yeah, I was looking at the periodic table in my hand.
Right, and that's what I would do. But that's okay. Hey, they told you what to do next, right?
Yeah.
So, yeah, see? Okay.
Well,
So
alrighty.
yeah. And we just put them in order, but that might be an exception. Okay, look at this. This one's perfect. We drew the arrows. Atomic size increases like that. Ionization increases like this. Metallic behavior increases towards the bottom. So this one also. Electron affinity increases just like that also. Why on earth is the blue and the green?
Is the last one yellow?
Oh, that's what this is. This is, yeah, this is right. Yeah, this is right. Yeah, these are right. These are right. Up and
Is the last one the yellow one?
And oxide basicity. You know that? I have no flipping idea. We did not look at that trend.
Alrighty.
Let me think about it. Oxide basicity. So that means.
Well, it's not yellow, in case you were wondering.
No, it has to be one of the others. Oh, come on. Because it goes with it. I just got to think. And I'm not thinking. Hold on. The more electronegative it is, I'm thinking the more electronegative it is, the lower basicity. So, where are you? Hold on. I have to think on this one, and it's not working. I am not in a thinking mode today, as you noticed.
It's the blue one.
It's the blue one, right? Yeah.
Yep.
Like this one. Okay. So that was right. See, I was right. The more electronegative you are, because this is backwards, see? So the less electronegative you are, the more basic you're going to be. That makes sense. Okay. Yep. That makes sense. Okay. Boom. We didn't even check them. I did. Do you want me to check them?
They were right.
They were right. Okay, so you did those already. Okay, right. Okay, rank them again. Okay, so again, same arrows. We left them there. Okay, so let's see who we see first on this side. Okay, so silicon looks like maybe because it's lower. No, silicon is not. It's carbon. No, it's oxygen. Oxygen would be first. Decreasing, right? So we're going with the first one, the highest one. Then I would guess silicon because it's right below it. Then carbon, which is a cross. Then calcium. No, then magnesium, then calcium. Okay, let's see if that works. Nope, these
Carbon and silicon and backwards.
Yeah, those okay, but I mean, it's just one of those. Actually, it shouldn't be because silicon is below, but hey.
It keeps doing that to you.
Well, that's because they're actually doing the real one. They're not saying look for, they're actually wanting you to look for it. Yeah, they're actually wanting you to look for it. That's the thing with this one. They're not telling you just use the periodic table like when I did it. And in order to know this one, you could go to the periodicity one. I'll show you where to go. Hold on. Where are you? Moodle. I'll just go into somebody else's class, some other class. Because, I teach more than one of you of this class. So I'll just go into this one. Let's go into this one. All right. And we're going to go to the periodicity PowerPoint, and I'll show you that's probably an exception. Nope. Ah, past you. There we go. There. A little bit more. Okay, there it is. That one, periodicity. All right, that one there. I'm going to look at it in a minute and you'll see. So we do have kind of values on
Yeah.
someday. All right, so where are okay, there's the sizes. There's the ionic sizes. Ah, there we go. This one. See how oxygen?
Yeah.
See, higher than nitrogen. Nitrogen's higher, but it's an exception. See?
It's little things that'll get you.
Yeah, but they're right there. So if you want to look at that while you're filling this out, that would be okay, because obviously that's what they want. So we'll just leave it in the works. Okay, go back to chapter 7. Okay, so next, or you can just flip the two that are wrong. Usually that's all there is. All right, again, atomic size. This time is atomic size. So we're going the opposite of these. So I'm going to put it in different color. So we won't forget that this is the size that this is the red one. So we're going to go actually this way. And
so it's going to be oxygen first.
Yeah, so the smallest, no, we got to get the largest one first.
So potassium.
Potassium, correct.
No,
Then
potassium goes where the little arrow is at the end of it.
increasing. Oh,
you're doing it backwards.
Yes, because I'm reading again. Potassium, aluminum.
And then after it, before aluminum is
I guess oxygen.
phosphorus. Is that what I'm thinking?
Oxygen be the largest.
Yeah, phosphorus is the one that where you were trying to put oxygen, and then it's nitrogen,
and then above, and then over. Okay, let's see if this worked, because we have the actual sizes too. But I think
boom.
There we go. Sometimes it does work perfectly, like I said, but it's a trend. Trends are not perfect. They have exceptions. Okay. Oh, we're going to do that. Okay. Basically, that's just alkali metals, there's a lot of stuff to write on there. No, I'm not going to do that one right now. You just read your book and it's all in there.
Yeah.
All right. This one, oops, same thing.
Same thing.
This one too.
Keep it moving.
Yep, because that's a little too much. Okay, so this one just made it pretty.
Okay, so it's the exact same thing, but they're showing you what it looks like.
Yeah. Well, yeah, exactly. This is atomic radius. So there we go. Okay, so indium. Oh man, indium, way down there. Indium is way down here. Okay, way down here. Indium, and over to the. Okay, who is thallium? Where are you, thallium? Oh, below that. So thallium seems to be the smallest. Thallium, yep. Thallium first, then indium, then gallium, then aluminum,
Then
and
the
then
B.
boron. Yeah, I believe so. Yep. All right, check my work. Better be right. Okay.
Nope.
Okay, you see, so they want to do it, but see, that's how it would be, because thallium's below. You see that? Thallium.
But they want to do it the other way.
Yeah, but thallium is below. They want to actually do it with the actual sizes. So in this case, you would have to go back to the periodicity PowerPoint and go to the sizes, which are, but these are relative sizes though. These are,
oh, man.
See, can you tell?
No.
It's kind of hard to see. See, this one says that thallium is larger. You see that?
Mm-hmm.
See, so let's see. Thallium is, yeah, that's third row. No?
Okay, I got it to finally tell me I was right. It wants it as boron the smallest, then I think that's aluminum. I can't
Boron, the
really.
smallest.
That's what it says. It wants the
Atomic
boron one,
radius? No.
and then it wants the one that's the AI or AL, whatever that is, and then it wants gallium,
They're
then
wrong.
indium,
They're
then
wrong. You know they're wrong. Because look at the trend.
the following group increasing atomic radius. They have it.
Oh, yeah, I did it backwards. I'm crazy. I'm the one that's crazy. I did it backwards again. Because
It's
I'm
gonna be
thinking,
okay.
no, because thallium would be the largest. Because it's the lowest down.
I
Okay.
think it's. I think it's because they keep switching the graph where they're doing the largest on one side and the smallest
Yeah,
on the
and
other,
I
and
think
they're
that's what
flipping it.
happened to me. Yeah, that's correct. Okay, so boron, yep. See, I had it right.
So thallium's last, then indium, then gallium,
Yeah,
gallium, however you say that.
how I had organized. Indium, come here, you go there. Oh, fine. I got to get them all off, I guess. Indium, you go there. Okay. Then gallium, then aluminum. Aluminum first, then boron,
Yep.
like that. So I had them right. I had them right, but backwards
Yes.
because I wasn't looking.
That's okay.
See, I told you I'm not in a thinking mode today. I just don't know what it is. Maybe I didn't sleep well. All right, next.
Select the compounds below their alkali metal.
Halides. Okay, so alkali
Thanks.
metal halides means that you have a halogen and an alkaline metal, alkali metal. So
Ooh.
only one is, this is one
Okay.
metal and a halide. Where's another alkali metal? Well, they're only lithium, sodium, potassium, rubidium, cesium, and francium. Any of those in any other? No. Then that's
No.
it. Then that's all. See?
Cool.
Because basically all they're telling you is the two components. So it's an alkali metal and a halide, a halogen. Okay.
Okay.
Carbonates and sulfates. Okay, so alkaline earth, though. Alkaline earth is going to be beryllium.
Okay.
That's not on here. Calcium.
Calcium's on there.
Barium. Barium's also. That's a sulfate. That's it. It looks like, because sodium is a chlorine, and that's not one of them. Yeah, potassium. No, those are ones. See, both of these would be alkali metal halides. You see these? The sodium chloride and the potassium chloride. But these two are carbonate and sulfate. Yeah. Okay.
Okay.
Yeah, that's correct. Why are they putting those here? That's weird. Okay, so that was those, all of those. All right, so they did not give you a single problem with what we wanted. So, except for the other thing. So it must be, so I'm just going to save and exit because it doesn't want to exit now. We're just going to go to the other one. Let me clear all these. Boom, there. Okay. Where is it not going? What's going on? Is there some I didn't do? Because I said save and exit and it didn't go back. Okay, fine. I'll go back. I'll just.
But save and exit doesn't submit it, right?
No.
Okay.
It doesn't. Okay. Your session has ended. Oh, I see. So you gave me a limited. Oh, there we go. This is where I was. No, this is yours right here. Oh, I had to get the periodic table. That's right. We don't need it, I don't think, anymore. But you have one, so just go back to that one. Because now I don't have to scroll down as far. Okay, so with this one, actually I need to scroll up, not down. Okay, there we go. So I need to go to connect. Because see, it kicks you out if you're not doing anything. And I was doing something, but something happened and it didn't return me. Okay, so what we're gonna do is gonna go application 7. And this is the one that has those problems that I wanted you and I to do together.
Oh, the application problems?
Yes. Okay, so let's look at this one. Oh, I know it's late. I mean, do you want to keep going or?
Oh, yeah, we're fine.
Okay. I just noticed it's 11. I was like, "Ooh, okay."
But, you know, at least I'm learning.
Okay, so this is it right here. You see this? Calculate the frequency of light. Okay, look what they're giving. They're giving you wavelength and frequency.
Mhm.
And wavelength, that's all they gave you. So what frequency, what formula can you use that has frequency in wavelength and nothing else, right? Because the other one's a constant. So it's C equals nu, which is frequency, times lambda, right? That's wavelength.
Yes.
And they want you to calculate this. So we need to solve for that. Remember that triangle?
Yes. Kind of.
This triangle is helpful here too. Okay. So all it has to do is has to look just like, see? So nu, right, is C over lambda. You see that?
Yes.
So we are going to use this, which is frequency is equal to C, which is the speed of light. And I always call it 3.00 times 10 to the 8th meters per second. It's a constant.
Okay.
You would know it. And then lambda is the wavelength that they gave you, which is in nanometers, 150.4 nanometers. Okay, so now you just divide. If I can find my calculator, that would be nice. I don't even think it's in here. I have 2 calculators and I have lost one completely. I cannot find it anywhere. I think it might have fallen to the back of this place. Okay, well,
Son, you
okay.
have so many toys in there. Please stop eating plastic. Thank you. It's like having a child.
That's funny. My kitties love to lick plastic. They don't eat
If
it.
you saw the
They
state of my home right now, I cannot, I couldn't even begin to add up how much the amount of toys cost that is in this living room.
There we go.
And he's chewing on a plastic candy wrapper that he found from somewhere. Goodness.
I was trying to see if I could get the EE, but it's not going to work. So 3.00 by 150.4. Okay, that gives me this number. What? 0? See. Clear. What? 3. I'm just going to put 3 divided by 150.4 equals. There it is. Okay. So now we got to do the math. Okay, so this is going to be harder because I don't have my calculator, but it's easy in a way. It's 0.0199. Also 200, I guess you could say. 200. And that's times 10 to the 8th. And remember, we cannot have it looking like this. So we need to increase it by 1, decrease it by 1. So it's 2 times 10 to the 7th nanometers. Okay. So
is it
that's
200 or 2?
2.0. Yeah. Okay. So they gave us 4 sig figs. And the way that my answer is 1.994 So 995, I guess, is what they want. Right? Times 10 to the 7th hertz. And then they want to know which radiation that is. To do that, you have to go to your electromagnetic, and there is a book thing. Where's the book? You can find the book in here sometimes if you find it. Let me see. Save and exit. Help. No help. I don't want help. I need the book because you can't memorize this. All right. So how about I just go here, go to the book. Will it let me? Nope. Okay. Let's go back to another.
Hey, go back to where you were in the beginning. There's a little button right there in blue that says ebook.
Where?
Go back to exact like the application problems where you were at.
Okay. So I got to go back.
Yeah, push the back button.
Yeah, you know that this is going to give us a different problem now.
That's fine.
Back button, hopefully. No, I don't think it likes it. See, it doesn't let you go back.
If you go back to the application, wherever we were just at, are we on? Yeah, the application problem.
It won't let you go back the way that you could just hit back, but it's okay.
Click on the application problems.
We can
continue and all that good stuff.
Yeah.
But if you look over to there's no screen. If you look over to your left, I think that is.
Oh yeah, I see it. Okay, so this time we're gonna have to divide by 91.9 nanometers.
Sorry.
It's okay. It's okay. I didn't see it because it was being covered by that thing. It happens.
Oh, okay, I see.
Yeah, see this thing that I travel, it covers it. And now I see it. Okay, so 91 point, okay, so down here it needs to say 91.9, right? Nope, not a check. What? I want my pen. 91.9 nanometers. Okay, so now let's divide. All right, so clear this. Okay, so it was 3.00 divided by 91.9. And this time we only have 3 suffixes to give up. So again, the answer is 0. Okay, so here it goes again. I have to do this math thing. 0.0326. Okay, that's good enough. Times 10 to the 8th. Okay, so we got 1, 2 increase. So we decrease by 2. So it's 3.26 times 10 to the 6. That's the answer here.
I have a different problem than you.
6. Yeah, I know.
That's terrible.
Well, but that's okay. You know what? My process, you know what I'm doing, so do the same thing. If it's the same, I mean, is it still getting you to calculate the frequency?
Frequency of light that has a wavelength of 192.3 nanometers.
Okay, that was the one we just did.
Oh.
Did before, which I had already. Well, that's okay. Do the 192.3. So just divide it by 192.3. Put instead of 91.9, put 192.3 down there. And it's going to give you what I had, which was like something points. So 192.
It was 1.955 to 7.
Yeah, you need 4 sig figs. Okay, yeah. So now to figure out what wavelength that is, we need this guy. Okay. And we need the electromagnetic spectrum, which is in chapter 7, not chapter 2.
Click on the 3 lines at the top.
Yeah, I know. I need to find. Oh, come on, you. Stop it. I'm trying to bring it down. 7.
You and computers have not had a good time this semester.
Nope.
Like technology has rebelled this
semester. There it is. Okay, you see it? Can you see it right here?
Okay, so you go by the little 10 to the whatever power?
Exactly, because these are nanometers. Okay, so mine was 10 to the 10 to the 6. So it'd be microwave. Yours was to the 7, so it's still microwave.
Cool.
Wait. Frequency. No, we're looking at frequency, not wavelength. Sorry, wrong one. Frequency.
Oh yeah, this is
was-
what type of
Yeah,
radiation is it?
mine was 10 to the 7, so it's radio. Yeah, it's radio frequency. Yeah,
Well, it's asking you what type of radiation it is.
right. Because
So
of the
it's asking you for a
frequency. Because
color.
we calculated the frequency. A
Yeah,
color.
but yeah, it says violet, green, ultraviolet, blue, or infrared.
Oh, you stupid thing.
Hey.
It's hertz. It's hertz. Oh, so then you need to look for the 91.9 nanometers. So times 10 to the 6. Okay, so let's go back to the book. Okay, so 91.9. Let's just keep you out of there. Visible. See, this is the visible. 91.9. See, that's just 919. So it's here in this region for me. But it's beyond it. See how it's beyond?
Yeah.
Okay, beyond both sides. It's 91.9 nanometers. These are nanometers right here, and they're not within the visible region. God, these people are stupid. No, I'm serious. Look. It's not. It's actually ultraviolet or something else, because 400 is ultraviolet, so that's 4 times 10 to the, what is it, 1, 2, decrease, increase. So 4 times 10 to the 8th is what that would be. And this would be 5 times 10 to the 8th, 6 times 10 to the 8th, 7.5 times 10 to the 8th. Meters, I'm saying, because we calculated it. I mean, nanometers.
So on mine, ultraviolet was correct, but my math was wrong for some reason.
Huh, interesting.
And I don't know what I did wrong. Because I just
So
copied you.
mine is ultraviolet too, because it's nothing else that it can be.
Because I did your steps, but I did my number, which is 192.3. And I got 1.955 to the 7th, but it says that was wrong.
See, okay, so I got, see? Okay, see, that's the thing is I'm doing it without a calculator. So when I, without an actual calculator that can do this. So 1, 2, decrease. Oh, yeah, that should be 4. What in the world did I do? No, I increased it. 1, 2, decrease, increase by 2. So, oh, it's 9. I did it backwards. It's 9. That should be correct. Do yours the same way.
What?
Yours, what was the original answer?
It said the original answer that I got was 1.955 to the 7th, but it says that was all wrong.
To the 7th.
Mm-hmm.
Okay, so that means I went the wrong way with that one. So it was 0.199. So 0. Increase, decrease. No, I think you had to the 1, 2. So it was probably to the 8th. Try to the 8th. Because mine is to the 9th.
It says that's wrong too.
Uh-huh. Okay, got it. All right. So, but if the number is right, why is my, because I know, okay.
It says my number's wrong too, so.
Do you know? Well, my number is right. So let's,
Yeah,
which means it's correct. It's just that I'm having problem. Okay. Speed of light. Let's go find it. And maybe I'm recalling wrong, but I want to say it's to the 8th. Where's the book?
in that little blue button.
Yeah, okay, let's get it smaller. Oh, clear this stuff out. Okay, let's go. How do I make you smaller? It won't let me. It won't let me make it smaller now. Okay, there we go. All right, so the speed of light. It should tell you here. See, there's the Roy G. Biv, you see?
Mm-hmm.
The speed of light, where are you? There it is, see? To the 8th meters per second. So I was right on that one. So it's 3.00 times 10 to the 8th meters per second. You just divide the two, whatever they gave you, whatever you got, you know, let me see again. Let me go back to my calculator. Give me your number, so I'll do this one.
192.3.
So let me make it a little bigger. That's a lot bigger.
A little
One.
bit.
Okay, so it's clear. It's sorry, it's 3 first. 3.00 divided by 192.3, right?
Mm-hmm.
Okay, and then equals. Okay, so see, yours is 2. So 1, 2. So it's 156. See, it gave me a different number this time. Maybe it wasn't the same one like I thought. Okay, so 1, 2. Yeah, you move it 1, 2 to the increase, so then you decrease it by 2. So since it was to the 8th, now it's to the 6th. So it's 1, yours is 1.560 times 10 to the 8th. Mine, let's do mine.
Mine is still wrong.
What? It can't be. I
Yeah,
mean,
it,
just
the
divide it.
150, the 1.560 is right, but the 8 is wrong.
No, it's not 8. Wait. No,
You
it's
said it?
not 8. No, it's not 8. It's 8 and you add 2. So 10th.
Oh, my fault.
Yeah, because 1.560 times 10 to the 8th. So you're adding 2. So it's, yeah, it'd be 10th. And
My fault.
mine was 3.00 divided by 91.6. What was it? Where are you? What the heck? Where'd it go? I forgot what mine was. Was it 91.6? I want to
Yes.
say
Thank
it was 91.6. Yeah, I think so.
Okay, so you're doing, to do this, you're doing 3, and then you're doing times.
Yeah, okay. So the answer that you're going to get, right? Yeah, that is correct. Okay, so the answer that you're going to get, you got to limit the sig figs, not to the constant, obviously, but to the other one, which you only had, you had 4, I had 3.
Mm-hmm.
Okay, so that's 326 for me, right? I mean, 328, sorry, see? That one says 327. So it was 1.5 maybe. Okay, it was different from mine, but that's okay. The problem is that we got now, okay, so now we need to convert it. So this is times 10 to the 8th. So we need to go 1, 2 up, right?
Mm-hmm.
Okay, I'm trying to get this draw thing. Okay, so 1, 2 up. So that's increasing. So we must decrease the 10 to the 8th by 2, right?
So is there like an equation that you can plug this into so that?
Well, there would be if I had the right calculator, but I don't. But this is the equation, though. We
There.
did the equation. So that would be 10 to the 6th. So in my case, it's 10 to the 6th, according to me, to my own, division thing, because that's how it is.
Mm-hmm.
I mean, because it was 10 to the 8th, and I'm increasing it, right? So it's 10 to the, I'm increasing, so I got to decrease. So we decrease, we add. No, we don't add. We increase, decrease. So that was not 10 to the 8th. Yours is 10 to the 6. Mine is 10 to the 6 also. Let me see. Clear all this. And I want to get my calculator back out. Oh, I want to make it smaller. Go away. Thank you. All right. So see, that's all we're doing. We're doing this same thing right here. See, this exact problem that is in gray here. I mean, in kind of beige here. That's what we're doing. It's just that. So it's 3.00 times 10 to the 8th divided by whatever the wavelength they gave us. And they gave us a different wavelength each. In my case, they gave me, that's got to be 6. It's got to be.
Mm-hmm.
what did they give me? 91.9. It was 91.9. Okay. So they gave me 91.9. So it's 3. Don't need the zeros in this case because it's just 91.
Wait, so it's 3 and then
And then equals. See, there it is, 3.26. Yeah, that's right. All right, and that's times 10 to the 8th. So if we
wait.
increase it, oh yeah, because we haven't divided.
Wait, so did you do 3 times 91.9 or did you
No,
do
3
3?
divided.
Oh, 3 divided.
Yes.
Okay, well
So,
that would explain why all of my stuff is completely wrong. It's because
okay.
I
Yeah, you have
am
to
pushing the
divide.
wrong button.
Yeah, you have to divide. Yeah, it's 3 because it's on top of each other, right? In the formula. So 3
Okay.
divided by whatever wavelength you got.
I don't know why, but my brain wanted to multiply, and I was like, why are all my answers different? Like, why is it wrong?
Yeah, that's what it is. Okay, so now I got it, I think. It should be to the 6. It better be, because that's what I get. If it's not, I don't know what it is. Check my work. It keeps saying, no. Oh, okay. There it is. You see what it says? Did you forget to convert nanometers to meters?
Maybe.
Yes, I did. Yes, I did. Okay, so that's in nanometers. Okay. But they want it in meters. It doesn't say meters there. See, that's the problem. So that is in nanometers right there. Okay. That's what it is. I did not convert. See, you cannot divide meters into nanometers. And 3.00 times 10 to the 8th is in meters per second. And this is what we're doing. I'll show you, which is really, really bad. Good thing I just realized. And God, sometimes. I mean, it's not that I'm not smart, but sometimes it's just, okay. So it's like this. So it's 3 point, this is what, see, Kitty, you are rubbing against my arm and I love you, but you're making my arm go down every time I'm trying to write. That's too cute. Yeah, that does not help me, you know? Yeah, let me write down my zeros. There we go. Meters per second, right? Divided by 91.9 nanometers. See, you can't do that. That needs to be times 10 to the negative 6 meters. Now when you divide, now you have, see, whatever we got was 3.26. Stop it. 3.26. Stop it. Sorry. Times 10 to the 8th plus 6. You see that? Sorry, 6 plus 6. So that's 12. That's what that's the problem. I bet you anything I am going to get it right this time. All right, it won't let me. I know it won't let me now, but it would be to the 12th. Oh no, it's still got.
Yeah, you have 2 attempts left.
Okay, never mind. Okay, let's go back. I just
Just
can't
put
see
12.
a lot of stuff because when I'm sharing, I can't see a lot of stuff. Okay, so I don't think it's here. Okay. All right, let me save it and exit and come back to it maybe. And it'll give me a different number, which is fine. I don't care. And I'm coming
Well, I
back.
hope it's 127.6 because that's the one I have.
Yeah.
And I keep getting it wrong again.
Let me clear all my drawings and go back in. Okay, I'm going to go back in. And hopefully this time, right?
I'm rooting for 127.6. Come on.
Nope, 256. Okay, but that's all right. All right, so now we know what we're doing for sure. Okay, so this is how it's going to work.
Okay, so for the, just
Okay,
for
so
funsies,
so
for the
it's
127.6, how many sig bits would I need? 4 or 3?
Okay. Kitty, stop it. Sorry. Okay, 275.6. You're going to need, see, I'm converting it to meters right here, right?
Mm-hmm.
Okay, so what we need to do is divide these two again. Okay, where's my calculator? So it's 275.6. Okay, gotta remember that so I can do this math thing. Okay, so it's 3 divided by 275.6. And whatever I get is an answer, okay? And the answer is, and I need 3, 4 sig figs, so it's 2,999,9999. It's 2.9999. It's a lot of nines. So the answer is 2.999 times 10 to the what? Well, it's 8 on the here, and then this comes up as the reciprocal, so plus 6 makes it 14. So there's the answer, 2.99 times 10 to the 14th. Okay,
Okay.
got it. Okay, so in this case, is 2.123 to the 14th. Now, what kind of radiation is this? We got to go back to that book thing. Okay, radiation area, 2.99 times 10 to the 16th, 14th.
Is it still ultraviolet?
I don't know. I have to look. It's to the 16th, but is this in meters down here? Are they giving it to us in meters? No, it says in nanometers here. And the frequency is below. But that has to be in hertz. So 10 to the 16th would be ultraviolet. Yep, still. I know. 14th is infrared. Look.
Oh, okay.
Okay, so let me go back and I'm going to check. Hopefully that's how it is. All right. Cross your fingers. Oh, what? See, less than about 400, blah, 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 blah. Okay, got it. It's just annoying. Everything's wrong according to this. And I did it right this time. So what on earth is going on with this? I did change it to meters. I did get the 14th, maybe the 1.3.
So if I got 0.0235 blah blah blah, and I
Okay,
need 4 sig figs, would mine be point?
let me do yours. Okay,
Okay,
so yours was what?
127.6.
Okay, so hold on. 3.00 times 10 to the 8th meters per second divided by 127.6
Mm-hmm.
times 10 to the negative 6, because nanometers, no, it's 9. Duh. See, there I go again. I did it again. That's why it's wrong. It's 16. That's 16. Okay, I told you 8 plus 9 is 17, right? Okay, so whatever you're going to get, the answer is going to be to the 17th. Okay, so let's divide 3.00. I need to clear everything. Yep. Okay, I'm so sorry. I am not here today. I don't know why.
I don't know.
127.6. Okay, that's the answer. Okay, so this is 0. Where'd it go?
Mm-hmm.
0.2351 for you, right? Remember that.
2.51.
0.02351. Yes, that's yours. Okay, so it's 0. No, check. 0.02351 times 10 to the 17th meters. Well, actually seconds, so it's hertz. But this is in meters, but it had to be done this way or it wouldn't work. All right, so that hurts. But now we got 1, 2 to increase, so we decrease by 2. So it's to the 15th. Yours is 2.351 times 10 to the 15th.
Oh. 2.351 times 10 to the 15th.
That's what it says.
Yes. And it's ultraviolet.
Okay, there you go. So it did work?
Yes.
Thank God.
That was stressful.
I know no, it was me. It's my fault. I was just not here. I'm not here. I told you. I don't know what it is. Just not here today. My brain is not working.
In your defense, I'm straight up in remedial math. Like, I do not do well with math.
Okay, so let's do this one. Okay, so now they want wavelength.
Okay.
From frequency. Remember that little triangle again, right?
Yes.
So if you do your little triangle, that way you don't even have to solve for x. And it was C is equal. So C is up here, right? Equals to nu times lambda, right?
Mm-hmm.
So if we're solving for lambda, it's C over nu. You see that?
Mm-hmm.
So lambda is going to be equal to C over nu. So this is equal to C, which is 3.00.
So 3.00
into the 8 meters per second. So sorry, 8. I forgot the 8. See, I told you it's just not here today. And then the bottom is 9.33 times 10 to the 14th.
minus 4.62 times 10 to the 14th.
Right. So now we divide those two. So let's get the calculator. So it's 3 divided by 9.33, right? Okay.
Mm-hmm. Well,
but for now, it's all we need because we can't do the other part with this calculator. So it's clear is 3.00 divided by 9.33. Okay, so that is equal to, and we only need 3 sig figs, so 0. Where did you go? Sorry, 0.321, right? No, 2. 0.22. Okay, so that's the answer for this part. 0.322 times 10 to the what? All right, so this is 14 and that's 8. So 8 minus 14 is going to be equal to what?
8 minus 14?
Negative 6, right?
Mm-hmm.
And that is meters. We need it in nanometers. But let's just first go up 1, right? As we decrease it by 1, yes? So it's 3.22 times 10 to the negative 7 meters. Now, we now need to go to nanometers. So we multiply it times 10 to the 6. I said the 6 again. 9. Sorry. Which gives us 3.22 times 10 to the second nanometers. Something is off. Going from meters to nanometers. Oh, but it's negative meters. That's why. That's why. Like, it's weird. Yeah, I was like, for a minute, there's something weird here. Okay, so that's what I say. Oh, but they wanted in meters, so we didn't need to change it to nanometers. So it's the bottom number. You see that?
Okay.
I just noticed. See, it says in meters.
Oh, okay.
Normally it's not in meters, it's in nanometers, so it's to the negative 7.
Oh, okay, okay.
And that should be correct.
Yes.
See? My brain's coming back. Oh boy, sometimes. All right, I'm gonna go back to that first one so that we do one correctly all in one. But let's go to the next one. Okay, now it's energy. All right, energy. So E, look what they're giving us. They're giving us wavelength and Planck's constant. Okay. And the C. So they want the long one, right? They want the E, oops. And when this, remember we wrote them down. That's why I wanted you to write them down. So E equal to HC over lambda, right?
Mm-hmm.
So the two constants are on top, and then lambda is the 721, but we need to change it to meters because C is in meters, and we need to change lambda to meters. So it's 721 times 10 to the. So this is how it's going to go. E is equal to Planck's constant, which is right here. See it?
Mm-hmm.
6.626 times 10 to the negative 34 joules times second times second times, and I'm just going to put it in parentheses. So that's times 3.00 times 10 to the 8th meters per second divided by 721 times 10 to the 9th nanometers. So meters, sorry. We're going to meters, so it's meters.
Mm-hmm.
Like that. Okay? Because that was
Okay.
nanometers. So we're in meters now. Okay, so now all we got to do, and I'm just going to make it pretty. Okay, so 9th meters. All right, all we got to do is multiply and divide. So that's all we're going to do. We're going to worry about the exponents later. Okay, we're just going to multiply the numbers and divide them. All right, so I need
Okay.
the calculator.
It would be 6.626
Right. So
times the 3.00, and then that answer divided by the 721.
yes.
Okay. Minus 769, but same thing.
Okay, yeah. And mine is 721. Okay, so this is the answer without any exponents yet. And we need 3 sig figs, so 0.275 for me.
Okay. I've got 0.0244 blank blah 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 blah. So mine would probably be just 0.24, I think.
Okay, so it was 0.0275. Okay, so I just want to write it down here. Okay, I'm going to put it up here because we got to do a lot of math. 0.0275 times 10 to the what? Okay, so the negative 34 plus 8 is going to give you 22, right? Negative 22, am I right?
I think so.
Okay, and then you bring up the 9, negative 9. So that's going to give you negative 31, correct?
Mm-hmm.
Okay, let me do it in the calculator just to make sure, because I do this all the time. Okay, so 34, so it's negative 34. Right here, see negative, you can put that. 34, nope, I changed your sign. Okay, plus, we said 8, right?
Mm-hmm.
That gives us negative 26. See, I was wrong on that one.
Okay, so it's not negative 0.2,
No,
it's negative 0.6.
it's gonna, yeah, it's negative 26. Yeah, see, I did it in my head, but I knew there was something weird on that one. So I said, nah, let me check it. So they're not all here today. And then add, right? Negative 9 to it. Negative 17. No, that doesn't make sense.
No, you didn't make it a negative 9, you did positive 9.
I did. Oh, God, I did put a negative 9. Stupid crap. See, it doesn't do it. You have to do it after the fact, which is weird.
Oh.
Yeah. Yeah. Okay. So basically it's 26 plus 9, right? And then we just change the sign. How's that? 35.
Sure.
So it's negative 35. So there's the answer. So the answer is 2.75 negative 35. But except, okay, the thing is not right. Why? Because it's negative 34 plus 8 gives me negative 26 plus negative 9. That's negative 35. Oh, no, I changed it. Oh, I know. It's positive. You know what I did that thing? I changed nanometers to meters, not meters to nanometers like the last time. So I did that backwards. That's the problem. That should be negative on the bottom. That's all. So instead
I
of,
thought it wanted joules.
yeah, it's 26 minus 9. So what
Oh.
is 26 minus 9?
Oh, Lord.
17, right?
Mm.
Yeah, it's 17. All right,
Yes.
so go back. Where's the go back to the stupid thing? There's no go back.
I think you just click in the box where the wrong answer is and delete your answer.
Really?
Yeah.
Okay, cool. That's easy enough. Oh, yeah.
Yeah.
Okay, so we said, again, let's do the math. Okay. I'm going to do it again, just to make sure I don't screw it up again. It's negative 34. So 34, I'm just going to subtract, okay? And it's going to be negative. Just remember that.
Mm-hmm.
Minus 8 equals that. And then we're adding, but we're adding, so we're subtracting again, 9. And that gives me 17. So negative 17. Yeah, it was right. Okay, I just want to make sure it's right. I don't want to screw it up again. Oh, you little, what the hell? Did you use the correct equation? Yes, I did, you stupid idiot. Okay, negative 34 and 8. That is negative 26. And then we got positive 9 coming up, right?
Mm-hmm. Try negative 19.
Oh, did I forget to move something? I haven't moved it yet. That's the problem. I haven't moved it yet. No.
Yeah, try negative
Yeah.
19.
Do you know why? It's because I haven't moved it yet. I haven't moved this number yet. That's what I haven't done. It's a mess not doing it in the calculator. See, 1, 2 goes up, decreases by 2. So it is negative 19. But
Yo, do I
I
get
can,
bonus points for understanding?
but there you go. See there? There you go. That should be correct this time. Yeah.
Yeah.
It's because I didn't see, I thought I had moved it already, but I'm looking at it and I did not. But this is a mess right here. It's hard to see. In my defense, it's hard to see that. But at least we figured it out. Okay, so let's
Yeah.
go to the next one. See, all of these are these kinds of, okay, now we got frequency of light. All right. I'll let
Yeah.
you take the lead on this one. What would you do?
Oh, okay. Where's that little picture I had? I took a picture of the
Okay,
equation because
the triangle.
yeah.
Okay.
So if we're doing light, is that the
But we're just doing frequency.
or
That's what it's
frequency?
asking you. But you notice it has energy this time.
Mm-hmm. Is that the E equals H times the
No.
little V?
Yeah, the new. The little
New.
V looking thing. New. That's a Greek letter. Yeah,
Oh, new.
new.
Okay.
And you.
Okay. So
Correct.
it's energy equals.
So remember, you can do your triangle. That
Mm-hmm.
helps every time.
So
Okay,
it's
so if it's energy is equal to what?
energy on top of the triangle, and then the
Right,
H and the new are next to each other.
right. And since you're solving for nu, it's E over H. You see that?
Yeah. So you divide E by H.
Which is going to be equal, sorry, nu is equal to E over H. E is right there, 2.73 times 10 to the negative 25 joules. And joules is something that we have to watch. And then the bottom is H, which is Planck's constant, which was 6.626 times 10 to the negative, what the hell was it? Negative 30, 36? 30, you
I
know,
think that says 25.
20, no, it's 30, 32. No,
Oh, I thought you were reading off the problem. Never mind.
no,
You're
Planck's constant. I'm trying to remember.
yeah.
It's constant. We just had it. I
Uh,
can go look.
was
Hold on.
it 34?
It's 34. I don't remember. I gotta look.
I can't either.
It's gonna give it to us right here. It is 34. Yeah, you're right. It's Joule's second. Okay, good, good, good. All right, next. See, didn't have to go too far. All right, so negative 34 down here. Okay, so you're just dividing.
Mm-hmm.
So obviously this is going to cancel. It's going to give you hertz because hertz is 1/2, which is exactly what you got. All right, so you don't have to convert anything. You just got to divide those two. Do
Thank
you
God.
have a calculator?
Yeah.
Because I got this thing right here that I've been using, but
So mine
and
is
then you
3.
just if you have a calculator that'll do the exponents, use it. I mean, but if not, just do it like I do. 2.73, right? Divided by 6.626. And we just want the answer for this one. All right. And this time, remind me to fix it before I give you the right answer, because I will do that if I don't. Okay, 0. And we need 3 because we had 3 sig figs, 0.412. Okay, times 10 to the watt. All right, so it's negative 25 plus 34. So basically it's like subtracting 34 minus 25, right?
Mm-hmm.
So clear that. Okay, so 34 minus 25. That should be 9.
I got 8.
Oh, sorry. No,
Okay, I can't subtract. That's completely fine.
it is 8. It is 9. But you wait. But we still got one more thing to do, right? And this is if you don't have the right kind of calculator. So this is 9. But we have
Okay.
to increase, so we have to decrease. So it's 4.12 times 10 to the 8
Oh, so it is 8.
hertz. Yes.
Oh.
It is to the 8. But I haven't finished yet. Like I said, I do it a little because I don't have my calculator that does that. You apparently do. All right, so this is 4.12. Oops, 4.12 to the 8th. Hopefully that's correct. Did you get yours correct too?
I did.
Good. All right. We have one last one, and then we go to the first one. All right. This one.
Write the abbreviated electron configuration for each of the following elements.
Oh, yeah. It's easy, 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 easy. Okay. So let's clear. This one's a little one. This one's an easy one. Okay. Abbreviated or shortcut, right? So bismuth. If you find bismuth on your periodic table, it's element 83, and you go up, it's xenon. So what I'm writing here is xenon. So you write it in yours. I don't know if you got the same ones or not, but then xenon goes to 6s2, 4f14, 5d10, and 6p 1, 2, 3. There you go. That's the abbreviated electron configuration that you have to write here. So to write it,
Oh my goodness.
you're going to have to click and you're going to have to put brackets. Where are you? Brackets, bracket, xenon, bracket, close it. Then it's going to be 6. Sorry, I have to find all these things in here. 6s2, and 2 is got to be up. So 2 then bring it back down. And then it's going to be 4F. Bring it back up. 14. Bring it back down. And by bringing it back down, you can click this thing also, this little arrow. Let's see, 5D10. Click on that. Bring it back down. See this one right here that I'm going to click? See, it brings it back down too. And then 6P. And bring it back up. And 3. There. That's the correct answer. That's for that one. All right. The next one is radon. Okay, radon is just beyond. So it's the same, right? Same exact thing I just wrote, except 6 at the end.
So it's bracket.
Yeah, the same exact thing, 6. Because it's just beyond bismuth. It's 3 beyond bismuth. So it's the same exact thing we just wrote. So boom, brackets, xenon. Remember, it's got to be capitalized or else it's not right. And then we got 6S, go up 2, and down. 4F, go up 14, bring it down. 5D, go up 10, bring it down. And 6P, go up 6, bring it down. And that's it. Then last one is radium. Radium is going to be very easy because it's radon. This one is the noble gas, and then just 7S2. That's all you got to write on that one. Okay, so.
Oh.
So it's radon. Did I put radon? Sorry, I always get those two names because they look like each other. Radon and radium. See, and I said radon and I put radium. And then just 7S and go up and 2 and come down and you're done. Oops. What? No. Let's just clear that crap. It was not going to work. Not like it was. So RN, close it. Then 7S, go up 2 and down and close you off. There we go. Now check work should be correct. See?
Yes.
All right. And now I'm going to go back to 1. Because I did not finish it. We're going to do it right this time.
Got it.
We're going to do it correct this time. Now that my brain's coming back. Oh my God, I can't believe I had the worst time on this thing. Okay, so frequency. In this case, because of the meters that screwed me up. I forgot all about those. See, you got to watch units. All right, so we want to do the frequency. So nu is equal to C over lambda. Oops, lambda. Well, that's a pre-lambda. Equals to 0.00 times 10 to the 8th meters per second divided by it's 275.6 nanometers. So we need to actually multiply it times 10 to the negative 6 to make it meters. 9. See, I did it again. Why do keep I doing 6? It's nano. Nano means 9. I know this.
Maybe you just really like the number 6.
No, it is actually not. No, I don't. Not necessarily. Okay, to the negative 9. There we go, to make it meters. Okay, so we divide 3 divided into 2.75. That's easy enough. We just do that part. We did it already, but I just want to redo it. It's just one of those things, 3 divided into 2.75, 275.6, 275.6 equals. And there's the answer. See, this time it's not the same.
Yes.
Okay, so this is a 0. It went away. Come here, you. Okay, there we go. 0.0108889, right? Because it has 4 sig figs, so we need 4. Okay. Now times 10 to the what? Okay, so 10 to the 8th. 8 plus 9 is 17, right?
Mm-hmm.
And then we need to increase 1, 2, decrease 2. So it's going to be 1.089 times 10 to the 15th. And that should be correct. Hertz. So second minus 1, right? Which is 8. All right. Let me clear it again. It does say 3 divided by 275.6. Yep, all of that's good. All right. Let's clear you. Clear this. No, clear this. This is what I need to go back to. Okay. All right. So the answer is, again, 1.09089, right, to the 15th hertz. And that would be ultraviolet, I believe. Now let's see. Cross your fingers. Yes. See, I told you I could do it all in one sitting. It's just I had to think of all the little parts,
It's a lot.
Yep, it is. But there it is. That's why there's only 5 problems, if you noticed.
More than 5 would be a lot.
Yes, it would. Okay, so there you go.
All right.
That's all of them. And
Well,
that's how.
good.
All right. Well, I guess I will be seeing you or not seeing you, whatever it is. Because we just hear each other, right?
Yes.